All right. Welcome back, everyone, for another deep dive. And today we are going underwater.
Underwater.
Yeah. We're going to be talking about oceanography,
Oh, cool.
which, a lot of people, when they think of that oceanography, they think of like, Jacques Cousteau
Yeah,
in a submarine or, very serious scientists in a lab.
right.
But the reality is that oceanography is way more relevant to our everyday lives than I think a lot of people realize.
It is, yeah.
So we're going to be talking about all that and more today. And joining me is, well, an expert in all things ocean.
Happy to be here. Glad to dive in.
So, I think before we get into, the really nitty-gritty details,
Yeah.
I think it's helpful to kind of zoom out and look at the big picture first.
Yeah.
And I know that oceanography, it's not just one thing, right? It's kind of broken down into these like subcategories.
Yeah, so there's kind of like the three big umbrellas. You've got physical oceanography, chemical oceanography, and biological oceanography.
Okay, so those are like the three main branches.
Exactly.
All right, so let's define those a little bit. Like, what exactly is physical oceanography?
So physical oceanography is kind of like what it sounds like. It's really focused on the physics of the ocean. So we're talking about things like currents, waves, tides, all that kind of movement.
Oh, okay, so like the actual movement of the water.
Exactly.
Like that.
So, like, how does the water move? How does that affect the coastlines? How does it affect, the organisms that live in there? How does it affect the climate? Things
Right.
like that.
All right, that
Okay.
makes sense. So then chemical oceanography. I'm guessing that's like what's in the water?
Yeah. So, chemical oceanography is really getting into that composition of the ocean. So, not just the water itself, but also the dissolved salts, the minerals, all the different elements, compounds, all that kind of stuff. And it's really cool because you get into these like biogeochemical cycles.
Biogeo. Okay.
It's a mouthful.
That's a big word.
It is a big word,
Yeah.
but essentially you're looking at how these different elements and compounds move through the ocean system, how they interact with the organisms that are living there,
Oh, okay.
and even how they interact with the atmosphere and the land.
Oh, wow. So it's very interconnected.
It's super interconnected, yeah.
Interesting. Okay, so then biological oceanography must be all about the creatures.
Oh, exactly.
And,
Yep, so that's all about the living organisms that are in the ocean. So you're talking everything from the microscopic plankton all the way up to the giant whales and everything in between.
Yeah. Wow, that's amazing.
Yeah.
So like I remember as a kid, I would always just be fascinated looking at like pictures in books
Yeah.
of just like all the crazy sea creatures.
It's like another planet.
It really is. Like
Mhm.
down in the deep sea where, there's no light and
Yeah, it's bizarre.
all these bioluminescent creatures.
Yeah, so many cool adaptations to survive in these like really extreme environments.
Yeah, absolutely. Okay, so we've got our three branches, our three pillars of oceanography. So where should we start? Should we start with the physics?
I think a good place to start is with something that I think a lot of people have experienced, which is just like going to the beach and seeing the waves.
Yeah.
I think that's a good like entry point to physical oceanography.
Okay, so like waves, what are they? How do they work?
Well, so waves are essentially just energy, right?
Okay.
They're energy that's moving through the water,
Okay.
and that energy usually comes from wind.
Oh,
So you've got wind blowing across the surface of the ocean, and as it blows, it creates friction.
right.
And that friction starts to kind of build up these little ripples.
Oh, okay.
And then if the wind keeps blowing and keeps blowing, those ripples get bigger and bigger and bigger, and they turn into waves.
Okay, so like the stronger the wind, the bigger the wave.
Exactly.
Okay, so that's kind of like on the surface, right?
Yeah.
But like what's going on underneath the waves?
Yeah, so beneath the surface, there's a whole nother world of movement happening.
Mm-hmm.
And that's where we get into currents.
Currents.
Yeah, so ocean currents. These are basically like giant rivers flowing within the ocean.
Okay, within the ocean. Not rivers that are...
Not rivers that are separate, yeah.
Okay, so they're part of the ocean itself.
Totally part of the ocean, yep.
Wow, okay.
And they're driven by a lot of different things, differences in water density, wind patterns, the Earth's rotation, all these things kind of come together to create these really complex current systems.
So like what is the point of the currents? Like what's their purpose? What are they doing?
Well, they do a lot of things, actually. One of the really important things they do is they help to distribute heat around the planet.
Okay, how do they do that?
So warm water from the tropics, it gets carried towards the poles by these currents.
Okay.
And then the cold water from the poles, it gets carried towards the tropics.
So it's like a big mixing system.
Yeah, like a giant conveyor belt
Okay.
moving heat around.
Okay. And so why is that important?
Well, it's super important because it helps to regulate the Earth's climate.
Okay, so the ocean is like a giant thermostat for the planet?
Pretty much, yeah. Without these currents, the tropics would be way hotter,
Oh, wow.
and the poles would be way colder, and we wouldn't have the kind of relatively stable climate that we enjoy today.
Wow, so it's thanks to the currents that we can live in, a place where it's not 100 degrees all the time.
Exact.
That's amazing. Okay, so we've got the waves and the currents. What else is there in terms of physical oceanography?
Well, we can talk about tides.
Oh, yeah, tides. How do those work?
So tides are caused by the gravitational pull of the moon and the sun.
Okay, so it's all about gravity.
It's all about gravity, yeah.
Okay, but like, how does that work? Like, how does the moon pull the water?
So basically, the moon's gravity pulls on the water on the side of the Earth that's closest to it.
Okay,
And that creates a bulge, like a high tide.
okay,
And then on the opposite side of the Earth, the moon's gravity is a little bit weaker.
okay.
So you get another high tide there, too.
Oh, so that's why we have 2 high tides a day.
Exactly, yeah. And then in between the high tides, you get low tides.
Okay, so it's like the Earth is spinning,
Yeah,
and then the moon is pulling on the water.
exactly, yeah. And it's creating this kind of rhythm of high tides and low tides.
Okay. So that explains like the regular tides.
Yeah.
But then sometimes you hear about like king tides or spring tides.
Right.
What are those?
So those are basically just extra high tides.
Okay.
And they happen when the sun and the moon are kind of aligned in a way that their gravitational forces combine.
Oh, so they're both pulling together.
Yeah, they're both
Okay.
pulling together. And so you get these like really dramatic high tides.
Wow. Okay. So that's physical oceanography
In a nutshell.
in a nutshell.
Yeah.
All right. So moving on then to chemical oceanography.
All right, so chemical oceanography.
We're talking about like the soup,
Yeah, the soup of the ocean.
like all the ingredients that are in there.
all the ingredients. So, obviously the most abundant ingredient is water.
Right.
But then after that, you've got a lot of dissolved salts,
Like table salt.
like table salt, yeah. So sodium chloride is the most common one. But then there's also things like magnesium, calcium, potassium,
Right.
all these different salts that contribute to the ocean's salinity.
Okay. So that's where like the saltiness comes from.
Exactly, yeah. And then, in addition to those salts, there's also a lot of dissolved gases in the ocean.
Okay. Like what kinds of gases?
Well, the most important one for marine life is oxygen,
Right.
because just like us, a lot of marine organisms need oxygen to breathe.
Okay.
And then there's also carbon dioxide, which plays a really important role in the ocean's chemistry and in the climate system.
Okay, and you mentioned earlier these like biogeochemical cycles.
Oh, yeah.
What are those exactly?
So basically, biogeochemical cycles are these pathways by which different elements move through the Earth system. So they're moving through the atmosphere, the ocean, the land, and even through living organisms.
This is like a big loop.
Yeah, it's like a big loop. And these cycles are really important for maintaining life on Earth.
Okay. Can you give me an example?
Sure. So let's take the carbon cycle, for example.
Okay.
So carbon is the backbone of all life on Earth.
Right.
And it's constantly being exchanged between the atmosphere, the ocean, the land, and living things.
Okay, how does that work?
Well, so plants take up carbon dioxide from the atmosphere through photosynthesis,
Right.
and they use that carbon to build their tissues.
Okay.
And then when animals eat plants, they take in that carbon.
Right.
And then when organisms die and decompose, that carbon gets released back into the atmosphere or into the soil.
Okay.
And then the ocean plays a really important role in the carbon cycle, too,
Okay, how so?
because it absorbs a lot of carbon dioxide from the atmosphere.
Okay, so the ocean is like a giant sponge for carbon dioxide.
It is, yeah. And that's really important for helping to regulate the Earth's climate because carbon dioxide is a greenhouse gas.
Right, so the more carbon dioxide in the atmosphere, the warmer the planet gets.
Exactly. So the ocean is doing us a huge favor by absorbing some of that excess carbon dioxide.
Okay.
But there's a catch.
There's always a catch.
Right. So as the ocean absorbs more and more carbon dioxide,
Yeah.
it becomes more acidic.
More acidic, okay.
Yeah. And that can have a lot of negative impacts on marine life.
Okay, so we're talking about ocean acidification.
Yeah, exactly.
And that's a problem because,
Well, it's a problem because a lot of marine organisms, especially those that build shells or skeletons out of calcium carbonate,
okay,
they're really sensitive to changes in pH.
okay.
So as the ocean becomes more acidic, it becomes harder for them to build and maintain their shells and skeletons,
Okay.
which can have a lot of ripple effects throughout the food web.
Right, so it's like it's affecting the very base
Yeah, the foundation.
of the ecosystem.
Exactly. And It's not just ocean acidification that's a problem. There's also pollution, right?
Right.
So a lot of pollutants end up in the ocean. Things like plastic waste, agricultural runoff, industrial chemicals, all sorts of stuff.
And that's obviously not good.
Not good at all. It can harm marine life. It can contaminate seafood. It can even affect human health.
Right. Right. Okay. So those are some of the big challenges
Yeah.
facing the ocean.
A lot of stuff going on, chemically speaking.
Yeah, chemically speaking. Okay, so let's move on to the creatures.
The creatures.
Biological oceanography.
My favorite part.
So what can you tell me about, like, all the amazing diversity of life that exists in the ocean?
Oh, it's incredible. I mean, we're talking about, millions of different species living in all sorts of different habitats, from the sunlit surface waters all the way down to the deepest, darkest trenches.
Yeah. And they've all got these, like, crazy adaptations to survive in those environments.
Oh, yeah.
Right.
I mean, you've got things like, the anglerfish that we talked about earlier. Right, with the little light.
A little lure that attracts prey.
Right.
You've got, creatures that can withstand the immense pressure of the deep sea.
Yeah.
You've got, animals that can survive in freezing cold water or in incredibly salty water.
Right.
It's just mind-blowing, the diversity of life that's out there.
Yeah, absolutely. So, we've been talking about all these different creatures kind of in isolation.
Yeah.
But obviously they're all part of this bigger ecosystem. Right.
Absolutely.
So how does that work? Like, how are all these creatures connected?
Well, it all comes down to food webs.
Food webs.
Yeah, so basically a food web is just a diagram that shows who eats who in an ecosystem.
Okay.
So, you've got your primary producers, which are the plants and algae that make their own food through photosynthesis.
Right.
And then you've got your herbivores that eat the plants.
Okay.
And then you've got your carnivores that eat the herbivores.
Okay.
And then you've got your top predators that eat everything else.
Right.
And so, all of these organisms are interconnected through these feeding relationships.
Okay.
And it's a really delicate balance.
Yeah.
Because if one part of the food web is disrupted, it can have cascading effects throughout the entire system.
So, like, if there's overfishing of a certain type of fish, that's going to have effects on all the other creatures in the food web.
Exactly. Yep. And it's not just overfishing. It's also things like, pollution and climate change that can disrupt these food webs.
Right.
And that can lead to all sorts of problems like, declines in fish populations or, even the collapse of entire ecosystems.
Wow. Okay. So it really is like this incredibly complex system.
That's super complex, yeah.
Where everything is connected.
Totally.
And if one thing goes wrong, the whole system is affected.
Exactly.
Wow. Okay. So, we've talked about all these different branches of oceanography.
We've talked about the physics, we've talked about the chemistry, we've talked about the biology. And I think what's really striking to me is just how interconnected everything is.
Yeah, definitely.
Right, like what happens in the ocean doesn't just stay in the ocean.
Exactly.
It affects the climate, it affects the air we breathe, it affects the food we eat, it affects everything.
It's all connected.
So what can we do? Like what can we do to protect the ocean?
Yeah, that's the big question, right?
Yeah.
I mean, I think the first step is just awareness, right?
Yeah.
Just understanding how important the ocean is.
Right.
And how our actions on land can have impacts on the ocean.
Yeah. And then from there, there's all sorts of things we can do. We can reduce our carbon footprint.
Yeah.
We can reduce our use of plastics. We can support sustainable seafood practices.
Right.
We can vote for policies that protect the ocean.
Yeah, absolutely. And I think also supporting, organizations that are doing research and conservation work is really important.
Yeah, absolutely. Well, this has been a truly fascinating deep dive.
Yeah, it's been fun.
I feel like I've learned so much. And I think what's really sticking with me is just the sheer complexity of the ocean and how everything is connected. And it really underscored the importance of protecting this incredible resource.
Couldn't agree more. I mean, we really need to think about the ocean as not just this vast expanse of water, but as a vital part of our planet that we need to protect for future generations.
Absolutely. Well, thank you so much for joining me on this deep dive.
It's been a pleasure.
It's been a pleasure talking to you. And all of our listeners out there, thank you for joining us. Keep exploring, keep learning, and let's all do our part to protect our oceans.
Hear, hear. That's it for this deep dive.
We'll catch you next time.